Good morning. This is your stats sensei, Mr. Spensei, and this is the pre-quiz for confidence interval and hypothesis test. This is specifically going to be the confidence interval. The next video we'll run the hypothesis test. Because both scenarios are the same, we're going to do the conditions on the hypothesis test and not here just because of room on the paper. So a consumer group compared the longevity of two types of razor blades, an inexpensive generic blade and a more expensive name brand. So we're comparing generic to name brand. The consumer groups was interested in testing the manufacturer's claim that the name brand expensive blades remain sharper, longer than the generic brand razor blade. So they're saying the name brand has a longer life. 10 men who shave regularly were randomly assigned to either the generic blade or the name brand blade out of a group of more than 1,000 men who shave regularly. All right. After the blade went dull, the men shaved with the other blade. The number of shaves obtained before a blade became too dull to provide a closer shave was recorded for each blade in the table below. The differences are normally distributed. All right. So what are we looking at? Well, first off, this is paired because each guy shaved with one, then they shaved with the other. They shaved with the generic or with the name brand, and they were randomly assigned to each group. We need to select an order in which to subtract in, and we'll just go generic minus name brand just because that's the order that they have. So let mu d equal the true population mean of the differences. All right, that's the generic part. Now we need to put in context. So what are we interested? True population mean of the differences in the number of shaves and we went generic minus name brand. And we always have to put the order that we went in. If we'd gone the other order, that'd be fine. We just have to list it. So generic minus name brand. All right. Our equation for the is x bar d for the difference plus or minus t star standard deviation of the differences divided by the square root of n because we had um, um, 10 men. So we know n is 10. We know our confidence level is 95%. All right, but I can't use these values. These happen to be check values. I need to enter this data into my calculator. So I've done that. I've gone to stat edit, and you can see I have 112, 111, et cetera, 97. Then I also have 104, et cetera, for the second column. So the generic is an L1, the name brand is an L2. And I can check those because I have the check figures. And if I go stat, calc, one var stats, and let's just say I go second one, it's like, oh, there's my average of 107.1. There's my standard deviation 14.05. I can check the other column stat calc one var stats by changing it to L2, so the second two. And we have 111.2 and 9.34. So that gives me my check values. All right. I don't need the check values. I actually need the differences. So to find the differences, I go to the top of column L3 and I press second one. So L1 minus second two, that gives me L2. So now I have all of my differences. And it's based on those differences that we're actually going to run our test. So stat, calc, one var stats. Let's look at L3. And I have an average difference of negative 4.1. And I have a standard deviation of 12.8274. All right, I want to talk about that negative 4.1. We went generic minus name brand. So it turns out it appears this to be negative. This had to be more and this had to be less. So on average, it appears that there's 4.1 less shaves for the generic. Now the question is, how statistically significant is it? Well, we need to calculate our T star. And our T star is going to be going by inverse T. And it's going to ask for our area. And our area is going to be 1 minus, well, they wanted us to calculate a 95%, so 1 minus 0.95 divided by 2. It's going to ask us for our degrees of freedom, which is basically 10 minus 1, which is 9. So here we go. Let's do that. Second vars, inverse T, parenthesis 1 minus 0.95, close parenthesis, divided by 2, degrees of freedom 10 minus 1. And we end up getting a value of 2.2621. 2.2621. So I'm going to plug into the equation. And so my plug, X bar is negative 4.1, negative 4.1, plus or minus T star, which is 2.261, 2.2621, and then it's 12.8274 over the square root of 10. Great. Now the calculator will do all that computation for us, and we can go stat test and drop down to T interval, which happens to be number 8. We use data. Our data happened to be set in L3, and we needed to put a 0.95 for the size of our confidence level. And we end up getting a pretty large range of negative 13.28 to 5.076. So negative 13.28 to 5.076. You know what? I want to make a little note. 0 is contained. And because the 0 is contained, we can't say that there's a difference. All right. But 0 is contained in the interval. But that's our interval there. This is our lower bound. And here's my upper bound. All right. So in conclusion, what are we? Well, in conclusion, we are 95% confident that the true population mean of the differences in what? In the number of shaves lies left something out. Super important too. I have to say generic minus name brand. Lies within the interval negative 13.28 to 5.076. So while we actually, while there's some evidence to indicate the name brand works better than a generic, because 0 is contained, it's not statistically significant. So we can't say that the name brand lasts longer. We don't have enough evidence. We have some, but not enough. So the meaning, they're talking about the confidence, the meaning of the confidence level of 95%. And so that just means in repeated sampling. In other words, if we did this over and over again, so in repeated sampling, we expect this method to capture the true population mean of the differences in the number of shaves how much? 95% of the time. All right, so we're confident that we did this over and over again. 95% of them would capture it. In other words, if we did it 100 times, 95% of them, or 95 would capture it approximately, and 5% would not capture it. All right. Appreciate you watching and hope to see you on the next one. Thank you.